Okay, so here in problem 6 of exam 4, we have the angular momentum in 3 different situations. And it's asked for, in unit vector notation, what is the torque, and we're told this is a particle moving from around the origin in a clockwise rotation. All right. Well, key to this is the simple equation that the net torque is dl, right, is the time derivative of angular momentum. All right. So if the angular momentum, the magnitude of its angular momentum about the origin is 4 kilogram meters, that's the magnitude, right? But because it's going clockwise instead of counterclockwise, the angular momentum is actually negative, right? Angular momentum is actually negative. And so we're going to then have for A, right, tau net is minus, well, okay, this one's trivial because the angular momentum is not changing with respect to time. The angular momentum is constant. It's 0. So, okay, let's move on to B. B is a little bit more interesting. All right, tau. Take the derivative of 4t squared with respect to time, and that gives us 8.0 t squared, nope, t, sorry, 8.0 t, and this is going to be in kilograms meters squared per second squared, right? And you're like, well, where do we get per second squared? Well, where we get that is from the dt coming in there. That has units as well, right? But 8.0 t, and in the end, this is going to be, well, the way they've done the units, we're just going to do newtons meters. And all right, it's going to be negative because it is counterclockwise and it is in the k hat direction, or the negative k hat direction. All right. Okay, the next one, t to the 1/2. All right. So we're going to take that, take the derivative of that, tau vec net. Okay, so the derivative of 4 times t to the 1/2 is 1/2 4 times t to the minus 1/2. So 2.0 times over, right, the square root of t. And it's going to be Newton meters. Okay, again, the direction. It's in a k hat direction, but because we're going clockwise, it's the minus. And there you have it. That is the tau equals 2 over square root of 2 k hat, minus 2 over square root of 2 k hat. And that's it for problem 6.